I'm Gonzalo. I'm here to talk about the technological aspect of Hyperloop. So who am I? I'm the Propulsion Project Manager of Hyped, and over the past 8 months, I've worked with a team of about 10 people to design, build, and test the pod's magnetic propulsion system, which isn't as complicated as it sounds. And one thing I want to emphasize is that before joining Hyperloop, I didn't have the knowledge required to build the things that we've managed to build in the society, which is something that Hyperloop manages to do very well year after year, that it fosters and just pushes for the skill of self-learning. So before going into the idea of Hyperloop, I want to give you a brief summary of some ideas that existed before Hyperloop, and just to convince you that Hyperloop is simply an addition of pre-existing concepts. So first, we had the pneumatic transit, which was put in New York in the 19th century, but it only lasted 3 years since it could only move one capsule at a time. And then someone theorized the vacuum transportation system, and finally the most famous of the three, maglev trains. And as you can see, all of these have a common idea, that they're trying to make transport more efficient. However, neither of the three managed to remove air resistance, which is, well, just to get an idea how much energy it can take up, for a cyclist, about 70 to 90% of the energy loss goes into air resistance, which is why Hyperloop comes into the game. So Hyperloop is based on Elon Musk's Hyperloop Alpha paper, which was written in 2013. And the idea, as Michael stated, is that the way you can remove air resistance is you take the air out of the tube, and by making your pods levitate, well, you're removing friction, which means now you have a much more efficient system, you have much less energy losses, and well, now you can transport things much more quickly. So just a brief summary of how the paper proposed pods. It proposed that they're fast, they're electric, and they're levitating. So this is where the Hyped technical team comes. So who are we? We are simply a student society from the University of Edinburgh, and we build prototype Hyperloop pods every year. We're all students, and well, basically we're just a group of people who get together, and we like to build cool stuff. So before going into what Hyped has done in the technological aspect, it's very important to note that the things we've managed to achieve are, from my perspective, based on 3 simple things. 1, that the members are very driven and they find a lot of purpose in what we're doing. 2, that, well, they spend more time than the average person in the work. And 3, that we've been given the right tools. But as you can notice, 2 of these 3 things come down to the members. So now into the society. So in 2015, the society was founded, and this year we applied to the SpaceX pod competition, but because of lack of funds, we were unable to construct a full pod. However, we did manage to make it to a design weekend that we were invited to Texas, and we got an innovative design award for the design of an unloading and loading of a passenger pod. And well, this is where it all began. And the next year, with enough momentum, now more interest, and enough funds, we were able to build the first pod, which is, just to give you a brief overview. So this pod was built with a very heavy steel chassis. It had a magnetic levitation system, and the propulsion was provided by SpaceX, which was given by what they call a pusher. And it's, yes, as simple as it sounds. And these are a few pictures of what we managed to do in SpaceX. Unfortunately, because of a slight issue, we weren't able to make it to the pod. But however, we did make it to a 24 finalist of over 1,000 applicants worldwide, being just a student team. And again, this was just the start of what the technical team could do. The next year, which is the year I joined the society, the society basically tripled in numbers. So now we had even more interest, more funds, and well, even much more people to get it all going. So this year, we built the next pod called Poddy II. And some of the notable things are that first, it had a magnetic levitation system. It had a lighter chassis, and we implemented a new type of magnetic propulsion system, which, just to give you a brief explanation, because it is a pretty simple concept, but because the idea of the Hyperloop is that it makes, well, there's no friction, there's no contact, and it has to be really fast. Well, this is a simple 3D print of one of our magnetic wheels, and this is a type of, well, this is just mimicking the aluminum rail that SpaceX would give us. And it's a very simple concept. You move the magnetic wheels, and there's a repulsive force which pushes you forward. And this is how we managed to get propulsion. And we made our pod travel theoretically at about 70 meters per second, which is very, very fast. So what did we manage to do? Well, here are a few pictures of our pod, including a hypnotizing animation of our propulsion system. And on the bottom, you can see how we assemble the wheels. And well, last year we decided to put the magnetic wheels together, and I can remember very clearly that while we were assembling them, I saw one of the magnets fly right in front of me. So it wasn't the best idea. And here are a few other pictures of our pod from last year. You can see the very beautiful black outside, and that's the one that's just in the foyer. So what did we manage to do? Well, again, we made it to the finals in SpaceX, and first we were the only UK team to qualify. We were by far the biggest pod, and from over 2,000 applicants, we managed to make it to the 18 finalists, and we were ranked 6th worldwide. Unfortunately, because of another controller issue, we didn't manage to make it to the 2, but it's still pretty impressive what we managed to do just from a group of students. And now we get to this year, which is, well, definitely the most exciting year. Similar to what we did with the first pod, and then going on to the second pod, that there were some incremental improvements. We have decided to improve the pod. And because of historic reasons, we decided to call our pod the Flying Podsman. So another brief overview. This is something really interesting. And some of the notable things about the pod is that the shell was designed using a genetic algorithm, which is very similar to how natural selection works, in that it selects a very, very wide set of designs, and then it just chooses the best one, and it scraps the other ones that aren't good. And another improvement we did was on the propulsion system. And we use a very similar concept of magnetic propulsion, but now we created a new type of electric motor. And this, well, I think I'm a bit biased, but this is definitely the coolest one we've done up to now. So this is a picture of the shell, and, well, just a few things of what we've been doing over the past year. So what's next? What are we doing now? Well, again, we managed to make it to the finals for the SpaceX pod competition, and we're going to California in July to race our pod again. At the minute, the pod is being manufactured in our lab in King's Buildings, and if any of you would like to go and just see what we're doing in the lab, just contact me afterwards. So it's very impressive that only a team of students have managed to do all of these. And here are some of the things we've managed to do. For the interest of this presentation, we had three awards in a row from SpaceX. So a lot of you might be wondering, how does a very small student society from Edinburgh contribute to this technology? Well, we're not the only ones who are interested. It's already clear, and Michael stated, that there are already private companies who are interested in this, and they've already started building tubes, and they have already started doing full technology testing, such as, well, Hyperloop 1, which is now owned by Virgin. Virgin has a lot of funds, and, well, they have Richard Branson. He has really good PR campaigns. We have Hyperloop technology, transportation technologies in France, and SpaceX. So a lot of you, again, might be wondering, why are we even interested? Are there any benefits technologically to Hyperloop? Yes, there are. One of the big things is that because the initial proposal was that pods would be electrically powered, then it means that when you have this enormous system and all of this network of pods, they would need an enormous supply of energy. And because they'd be electrically powered, then it would lead to advancements in renewable energies, which is, well, something we desperately need at the minute. It will also lead to lighter pod structures, which is, well, that's becoming more important nowadays, and to even more advancements in electrical motor technologies. And, well, now, I've spoken very, very highly of Hyperloop, but there's a few other challenges that we're still meeting, and most of them come, well, the biggest one I see is in the tunneling, and because you have to build kilometers and kilometers of tunneling overground and underground, well, there has to be a very, very good implementation of how this is built. Then, well, because you're traveling at nearly the speed of an airplane, or even more, if you want to turn, you can't just do a straight turn. You'd have to do it over a large radius. And this would mean the way it's implemented, well, you have to be very careful in how you design the tracks. Finally, well, there's also the big challenge of pressurizing the tube and making sure it stays pressurized, and while implementing other types of evacuation systems in case anything goes wrong and you have to get your passengers or your cargo out. So now comes the big question of, is Hyperloop technologically feasible? To a lot of you, it might sound like something that Elon Musk might have thought about when he was stoned or something, which happens very often. And my answer, objectively, is yes. So, as I've said a few times in the presentation, the technology basically already exists. And it's all about how we put it together. And there is a lot of interest already from private companies, governments, that can provide the funding and the tools for us to build it. And it's a really good point to remember things like cars and airplanes and boats, which at the beginning, they were considered something ridiculous. And well, now we can't really imagine life without a plane or a car, etc. So yes, I believe it is. So well, if you want to stay up to date with the progress and what we're doing in the lab and such, well, follow us on social media. And yeah, thank you to the sponsors, and thank you for coming.